My name is Calvin Hendryx-Parker, and I am CTO and co-founder of 6 Feet Up. As if you hadn't seen 3 of my talks prior today, but I want to go over that again, just make sure that people who are watching the recording later know what's going on. And I am also the co-founder and co-organizer of IndyPy, which is the ones bringing you this awesome conference today. And I want to thank you guys for spending that time. Hope you enjoyed the virtual conference format. And one last thing before we get started with my talk, is don't hesitate, or please go now and sign up for a lightning talk after this talk. So there'll be a set of 5 lightning talks afterwards, and I hope to see you guys in those lightning talks. I will give one, and I will twist arms of other people to give one, and so we can fill up those slots, and then we'll have some couple closing remarks. But in the meantime, we do have one last talk time slot today during the web conference, and I will hopefully fill it with something that will inform and enrich everyone's lives. So my name is Calvin Hendryx-Parker again, CTO and co-founder of 6 Feet Up. We use a lot of SaltStack in our infrastructure, and I talked a little bit about it earlier in the Plone on AWS talk about how we build our repeatable infrastructure on Salt or on AWS with Salt. But I want to talk a little more in depth about some of the things we've done with Salt and some of the things that are possible. We're going to talk about how we can make our deployments as reliable, consistent, repeatable, scalable, and kind of ultimately that all comes down to as automated as possible. So you may be asking, what is Salt? If you weren't in the previous talk from last session, I assume they went over a little bit about what is Salt, but Salt's real place in the environment is event-driven data center orchestration. What originally attracted us to Salt, though, was the remote execution environment, the ability to log into a Salt master, run a command across 100 or 1,000 or 5,000 servers simultaneously, and get back that data, or manipulate some file, manipulate some state of the server. We less and less use it for remote execution, and we may use remote execution to bring in inventory information about a server or a set of servers or the whole cluster of servers. More and more, we're moving toward the configuration management aspect of Salt and the orchestration aspect of Salt, and then using the events coming off the Salt event bus to drive making decisions or performing actions against a set of machines based on conditions in the infrastructure. So what is Salt similar to? I guess what sets Salt apart from other similar tools? I mean, you could be using Puppet, Chef, Ansible, CF Engine. If you're using cloud-specific ones, for example, like CloudFormation or Terraform, what really sets Salt apart, though, is some of the things I already mentioned, which is like the remote execution piece, being able to interactively query across your whole infrastructure and be able to get back data about what's going on in real time is really nice, especially if you're in the middle of troubleshooting something. If you want to be able to do orchestration, a lot of those tools don't do the orchestration piece. Some people are relying on tools like Fabric or Invoke for doing orchestration, but Salt can actually wrap that into part of its normal day-to-day operation. You can do Salt in an agent or agentless operation, although I like using it with agents. They're called minions, and if you guys have seen those minion movies, they're really cute and fun to play with, but I think having minions makes the operation of Salt a lot faster, because underlying the Salt master and all the minions, if you're using an agent style operation, is going to be the 0MQ bus, which is super fast and scalable, allowing us to actually perform those operations in parallel across a lot of machines at scale. If you opt for the agentless way, kind of more in the Ansible style of doing configuration management, you still have SSH as a bottleneck or whatever transport mechanism you're using to interact with your servers as a way of talking to them as kind of a potential bottleneck. And Salt also incorporates some nice cloud provisioning bits. So if you actually want to do a hybrid cloud or cross-cloud provisioning, you can talk to more than just AWS. You can actually talk to Azure, DigitalOcean. You can talk to on-premise private clouds. So if you have VMware running internally, it's got modules built into it to already talk to a lot of those pieces. And then I think another kind of selling point or area where Salt really excels is in the speed and scalability. It's because of that 0MQ bus and the ability to do the operations in parallel and all very asynchronous. That gives Salt a big advantage over a lot of these other tools that have to kind of run either in serial or talk to machines over non-asynchronous channels, which again, Salt gives you that ability to do that with 0MQ. So again, talking about Salt architecture, it does have a masters and minion style architecture. So the minions being the agents you would run on all the servers in your infrastructure. If you can't run a minion on a piece of infrastructure, for example, like a switch or a router, it does have the ability to proxy from any other server inside your infrastructure to those machines. So you still can control network infrastructure and pieces that don't allow you to run an agent on them directly. Typically, when you're first getting started with Salt, you'll have a single master, but it does allow you to scale up and have kind of sub-masters underneath it. So for example, if you had multiple data centers in multiple geographic locations, you may want to actually run what are called syndics in those various locations to handle the load of all the minions in one specific geographic area. And then they all pass their return data back up into that one single master. And then that one single master can send orchestration commands, configuration management commands down through to the syndics, who can now coordinate on the bus with their own set of minions individually. It's kind of giving that additional ability to scale and actually have multi-masters and syndics available through the whole architecture. If you want to follow along with this presentation and actually try out some of the things I'm doing, I've been keeping this repository up to date. It's underneath my GitHub, salt-orchestration-demo. If you have a lot of memory and a lot of CPU free, I tempt you to just type Vagrant up. From that, we check out the repository, CD in the repository, and type Vagrant up. It will spin up, and I'll show you during the demo, 5 virtual machines onto your own computer. There'll be the Salt master, which we'll use to then talk to the rest of the machines participating in the application. And then the application has 2 VMs that are the application servers, a database server that they'll be storing their data into, and then a load balancer node on the very front end that we will manipulate based on the status of those application server minions. So it does take a bit of memory, because you are spinning up 5 virtual machines onto your laptop or your desktop or whatever it may be. But it does give you the ability to play around with Salt really quickly. And we're gonna walk through and do some demo of like showing remote execution and actually doing some orchestration, event-driven orchestration. And again, if you have questions, I am in the automate and deploy channel on the Slack for the conference. So I'm kind of watching that at the same time. Feel free to throw your questions in there. It may be easier than using the Q&A on the webinar, because I may not see those. Maybe I'll drop that down here just in case. Cool. So feel free to ask questions along the way. And there's a lot of bits and pieces and moving parts to Salt, but I want to try and give you guys some examples of what's going on. So real quick, we will start off with the structure of Salt. And so the next slide, I should actually move into the next slide. Well, we'll stay right here for now. We are going to go onto the Salt master. So I am logged into one of the Vagrant machines that comes up as you type Vagrant up as part of the boot up process for checking out this demo. If you have it all, if you just did Vagrant up and started running, you would actually have a Salt in a state that's ready to play with and actually do interesting things. So for example, let's run through. So for example, I have the proxy server up and running. Well, let me show you that first. We can use globs to select what kind of machines we want to talk to. So in this, again, I told you there are 5 machines. There are 2 app servers, app 1, app 2. There is a Salt master called Salt. There's a DB server, which is a Postgres server called DB, and then a proxy server called Proxy running HA proxy. And Salt has modules built into it. So here we're going to play with the remote execution modules of Salt. So we're going to use the HA proxy module directly to show what backends are live on that HA proxy instance. So we have one proxy with one backend called Django. And if we look at the other ones in here. And so, for example, we want to list the servers that are on the back end of that proxy. We can actually use, again, as a direct module of SaltStack that allows us to talk to HA proxy using it. It's got a socket listing on the server, and the minion talks to that socket and can now give us data back about HA proxy and its status. I think we can get a full status. again, I'm going from the hip here, but luckily Python is, so that command doesn't exist, but I was just trying to give you guys a quick little example. And now if we want to do it across multiple servers, so for example, in this last example, we did a list servers across just the proxy server. But if we actually want to, for example, see what if the user dev1 has accounts on all the machines, we can gather the user info for the UID dev1 across all of our machines. And then this went out and ran them in parallel across all the servers in our cluster. And so we can see the return. So dev1, the user dev1 does not exist on the proxy server. He does exist on app1, on app2, and does not exist on the DB server. So now we can see that the developer has access to app1 and app2, and also to the Salt server. And the reason the user has access to the Salt server is we want to be able to allow them to run orchestrations such as a release process or restart the instances via ACLs inside of Salt without having to grant them access to more than they're really supposed to do. So we can actually do that with Salt, and I'll show that in a little bit here. But I'm going to talk a little bit more about some of the Salt terminology. Pull those slides back up. There we go. So Salt is composed of states, and those states you can think of as templates. Like if you're a web developer, these may be the templates that you're stuffing data into to then render onto the screen. In our case, these states are YAML files that we will stuff data into to produce infrastructure or to configure machines to handle various operations. Pillars are going to be the data that we are stuffing into those state templates generally. So you may have pillar information, including things like database users or IP blocks that should be used or passwords for specific environments. Now, you may get lulled into a false sense of security thinking that you can put things like passwords into pillars, but I would not recommend it. There are definitely better places to put secrets and password information. It is possible for pillars to be exposed inadvertently, but generally states are available across your whole environment. No matter what machine they are, they can read all the various templates and state files. The pillar information gets filtered down based on the host, and I'll show you how we can do that with the various top files. But don't think that this is a security mechanism by any means to manage those kinds of secrets. So once you've got your states and pillars, like basically building up the infrastructure, you can now put in place reactors that can listen on the 0MQ bus for events that are happening. So across the bus, there'll be events such as new minions spinning up, states being applied. You could actually build your own events with beacons. So the last one down here called beacons. You can actually now listen for specific kinds of operations happening on a server, send your own events into the event bus, and have reactors then can now react based on that. We'll talk a little bit about salt mines, and I'll use them in the demonstration. Salt mines are basically the easy way, I don't know if it's the only way, but the easy way to have minions talk to data from other minions. Generally, minions are talking to the salt masters. They do have ways to talk to each other, but the mine is an easy way for you to gather information from one minion about a set of other minions, potentially. Because normally the minions can't talk to each other or wouldn't know a lot of information about each other. And then those events coming across the event bus, as I mentioned, like the 0MQ bus that we can listen for and then react to. Let's see, make sure I'm not missing anything here. And I probably should have put this in differentiators for Salt, but when it comes to dependency management in Salt, it's really got a nice system for determining what parts of your state are required in or required by other areas. So for example, if you have an application and you're installing a Django framework application onto your server, that Django application is going to require Python. It's going to require a database client to be installed. So for example, if you're using Postgres, you have to make sure the Postgres client libraries are installed. So you'll use the requisite system to specify those kinds of things very specifically. And I can actually show you an example of that. So if we go over here to these states, and so for example, I have a state that sets up and templates out how Django will get set up. So the demo application we're showing here, actually maybe I should show that to everybody before I get any further. If we go to the application itself, So we built a quick and dirty little Django application that's basically a note-taking app. So if we sign in, I'll create an account. We'll make a super secret password. Oh, but I have to make it super secret or else the password requirements will not be passed. And we'll sign up. And then we can save notes. And so that's the basics of the application we're hosting, but it is a Django application. So I think we want to be able to show that how we set up a Django application with all the various dependencies in our application. And I can do that by showing you the Django state. So the Django state is basically a set of templates. And if we start with the init, it's the root. So if we call the Django state onto this application server, it's going to start with the Django init file. So if you see that there's these SLS files right in here. At the root of the states directory, you can either have a Django.sls, which would be one giant file with all these things in it, or for convenience, you can break it up into lots of little pieces. So I've done that in this case, is broke it up into lots of little pieces. It's going to look for the init.sls first, and based on that, start building our application. So we're going to include the Postgres client, the Postgres dev libraries, Python, all the things that are going to basically be underneath our application or required by our application. We can put into our state file here, and then define dependencies. For example, we need certain packages installed. And then we're going to need a directory to put our Git repository in. So we're actually checking out this project off of GitHub. But if the directory doesn't exist, the GitHub we can't clone that repository into there. So you can see there is the use of a require in, where we make a directory, make the user and group owned by the vagrant user, set the correct directory permissions on it, and then if the Git Django production Git state gets called first, it will look and say, oh, well, where are the bits I'm depending on, and I'll do those things first to build up the rest of the bits, and then I will go ahead and check out my code into the Django application. So that's kind of an example of using the requisite system there. It's great obviously for configuration management. You can actually set it up to not only require other states and parts to build up your application, but also watch for changes to configuration files. So for example, if you released an update that had a change to the Nginx configuration file, we can have a dependency that watches that file specifically. So anytime that file changes, it can automatically reload or restart the Nginx service on that server for us. So you can have basically the ability to listen and watch if you have multiple states that you want to restart a service specifically. So using the same dependency system now, we can actually now orchestrate across multiple levels in our application space. So for example, if we are doing a release to our production environment, we may want to take an application server out of the load balancer first before we release code to it, so we can actually turn down the application, release code, do any automated bits like grunt or gulp or whatever the compilation pieces need to happen, spin the instance back up, wait for it to be live, and then put the instance back into the load balancer. So I have an example where I can show that as well. So in our orchestrations, we can look at the production release. It's basically the same as a state file, except it can operate across multiple minions, where normally a state file, when you call a state against a specific server, it's going to interact only with that one server. And orchestration gives us the ability now to do that same level of control, but across multiple servers. So we can actually loop across servers. We're going to run this from the master. The master will then look at the orchestration and run this loop. This is just a Jinja template. So if you guys are familiar with doing web development with Jinja, you'll be very comfortable with the template syntax for the state files and the orchestration files that are going to be used inside of SaltStack. So we have two app servers. We're going to loop over app 1 and app 2. And in each case, we will release the code to the specific target server. And we will, before we restart the service, we will take it out of the back end of HA proxy. So in this case, we are targeting the app server for the pull the code and for collect static, which is a Django operation. And then the next step along the way, we actually target the proxy server running disable server, giving it arguments of the current app server and whatever backend we want to remove it out of. Now that we're not sending traffic to the Django app for this specific backend, we can run supervisor restart. So all of our Django instances are being controlled by the supervisor process control daemon. And then just as part of the demo, we sleep for 6 seconds, and then we can now talk to the proxy server again, re-enabling that backend, and we basically now loop through each server in turn, deploying our application or releasing the code to our applications. And this allows us to basically stage and do a zero downtime release of our code, because we're controlling every aspect along the way, from adding servers in and out of the load balancer, compiling code, running migrations, and we have greater control and can actually literally orchestrate how the whole thing actually happen. Let me show you how that works in real time. So instead of running a normal SaltStack where we would use the salt command to run it, we're going to run this on the master and have it run a loop over each of the machines in turn. So we will run the orchestration, what was it called? Production-release. I need the full path. And I'll tell you what, I'll use the -l debug so we can see a little more output and see what's going on. Oh, why is it not happy with me? Oh, because I need to tell it I want to do an orchestration run. I think that's the right command. All right, I will have to come back to this momentarily, but I will demo that later for you once I look it up. Okay, so that's the orchestration with dependencies. One nice thing is we want to be able to give access to our developers to be able to do things like run that specific orchestration. We can use the REST API with Salt, so not out of the box by default, but we can actually turn on a API backend to SaltStack that allows us to, from remote, talk to our Salt master and allow specific users to do specific kinds of operations. It has 2 different kinds of APIs built in. There's the, I think it's Cherry Pie, if it's still one it's supported, but they also have a Tornado server. So if you actually want to see the events coming across the event bus, you can subscribe to the full asynchronous WebSockets for all those event notifications. For example, if you're building a dashboard for inside your company where you want to be able to see what's going on, we can use this to now view the events coming across that and see the status and state of all the machines in absolute real time. There's a cool tool, and I didn't quite get it all working, but basically we can, watch for that. I don't have the thing installed. If you want to do the remote execution bit from your own desktop, like for example, if I'm on my own machine here, and I work on Salt demo. Oh, helps I type their command. Salt demo. So I'm on my local laptop and I have a package called salt-pepper installed. This gives me the pepper command, which basically allows me to emulate the salt command from the master. But I can now specify what server I want to point to, what API. I have to specify, for example, my username and password, and there's a couple different authentication mechanisms you can use. And then once I talk to the salt master, we'll go over here and look at the master configuration. I can specify inside the salt master configuration external authenticators that allow me to give ACLs to specific users. In this case, I'm using PAM, so it's going to be the user accounts that are on the Salt Linux box. I've got two set up, one for Vagrant and one for the dev1. And I can now scope them down to specific servers and specific sets of operations. So in this case, I've allowed dev1 to do operations against app, one star, 1, 2, 3, 4, 5, but they cannot run operations against the DB server or the proxy server. So now you don't have to grant everybody pseudo privileges on all the servers. You can now just dole out SALT access to run specific SALT orchestrations to specific developers or specific people who have the authority or authorization to run those various entries against those specific servers. State.orchestrate. Thank you, Matt, for giving me that last minute tip there. So if we back up to run that orchestration, which I have running over here, it was not orchestrate.run, it was state.orchestrate. It's a little about a live conference where I actually have assistants in the wings. So what we're doing is, again, we're kind of running back to running the orchestration across multiple servers, being able to do a code release in a staged, controlled fashion. Yep, that's working this time. I will, as soon as this is done running, I'll kind of go over it. But basically, it's starting on app 1, removing it out of the app server. I might actually be able to see it, do it. Oh yeah, you can. So I've got the HA proxy status up and running right here. And you can see that app 1's backend is currently unhealthy because we're running, we've disabled it so we can run the release against it. You see that it just got put back into load balancer. I don't know if I can, there we go. You can kind of see the stuff going on in the background still. So now app 2 has been taken out of the load balancer, and we rerun the state against it to release the code and put it back in the load balancer. So now they both went from disabled, enabled, disabled, enabled, and now the site's back live again. So that's an example of running that orchestration across multiple layers of our environment in a nice controlled fashion. Now, let me keep this on the bottom here. I'll show you another example of the event-based orchestration. If I can reorganize my windows. Okay, so now you can watch at the very bottom of the screen, I've got the status of the various load balancers. And then from the SALT master, I can perform some operations, but the effect of those operations is going to have an effect across the environment. I'm going to show you the example of those reactors. Well, I'll do the demo first, and then we'll look at the code, like the YAML that kind of powers what's going on there. And so SALT key. What I'm going to do now is I'm going to actually remove one of these backends by removing its key from SALT. So SALT maintains authentication of the minions via public-private key infrastructure. And so you can see I've got accepted keys for both app servers, the DB server, the proxy server, and the SALT server. But if I remove the key for app 2, this is only affecting the SALT master, but what's happening behind the scenes that you're not seeing is going to be a reactor that's listening for key removals. So for example, machines being moved out of our infrastructure, and it's going to then clean up that machine. For example, in our case, remove it from the load balancer. So if I remove the SALT key for app 2, watch down below, we should see some side effect of that happening in the HA proxy load balancer. So it may take a quick second, but the app 2 server is now gone. We have removed app 2 from our load balancer automatically just by removing it from the SALT maintained and managed infrastructure. So what did that exactly? So if we look at the orchestration, not orchestrations, it's going to be our reactors. So we have a couple reactors built in here. So we have, there's one for removal and then one for update. So for example, if a backend server gets updated, these are pretty simple. They're basically, again, YAML files with Jinja template. We are querying for event data coming across the bus, and we're looking for the ID of the event to start with app. So we're not looking for DB servers or the proxy server, and we're looking for a specific action, which is delete. the fact that we've taken and deleted a specific app server will cause the high state run against the proxy. So when the proxy runs its high state, it is actually leveraging the salt mine. Oops, not in Nginx, in proxy. The proxy maintains an HA proxy configuration file, and this is the very top of it. So it's kind of standard, plain Jane HA proxy configuration file. There's our Django front end, and then we've got our back end with our servers, but the servers are dynamic. Those servers aren't hard-coded in there. They are based on the environment. And so we use the salt mine to look for all the things that are of node type, which is a custom grain we added in Django on our specific network. And then we sort them. And then we loop over all the servers that it finds in the salt mine that are Django servers and add backends in for them. So for every server that exists in the environment, this state will run and either add them, or it basically just recreates that list every time one gets added or updated. So now if we want to add app2 back in, I'm going to go ahead and restart this salt minion on app2. That won't add it back into the HA proxy load balancer just yet, because we've basically unauthenticated it by removing its key. So if I look at salt key -L, we will see, actually, no, I guess I have auto accept back on. So the key got auto accepted, but I only have the update listening for high states, well, state.applies. And if we go back over here to the HA proxy update, if an app server comes across the 0MQ bus with an event and the function is state.apply, I'll basically do the same thing. I'm going to rerun state.apply, which applies all the states to that machine against the target server being the proxy server. So if we now go and run, so since we've added our server back in, we probably want to make sure it's in the correct state before we add it into the load balancer. And we can do that by running state.apply. And you should be able to, technically or theoretically, you should be able to run state.apply as many times as you want against the server, because we're always trying to guarantee it's in a certain state. I'll get a good drink of water here while we're waiting for that to run. Now, if you watch down here in the bottom, since the state.apply is run against app2, it has triggered a state.apply to run against the proxy server. So there you go. You can see automatically, because of the event-driven orchestration, we've added our second app server back into the proxy server automatically. Like, all I had to do is ensure that app server was in the correct state. And once that was successful, then the other bits of the infrastructure kicked in for us and did that to orchestrate. So to kind of recap, that's exactly what we did here. We use reactors to orchestrate our new salt minions being created, or we can actually use reactors to do things like heal broken services by attempting common fixes. So if you know that when this specific event happens in your infrastructure, running this restart or restarting this one service or clearing out disk space or whatever the normal standard case can be, you can now listen for that event to happen and run an orchestrate that can basically do it for you in the middle of the night, instead of you having to get a sysadmin paged, and go do some manual action. The Salt orchestrations can actually do it for you, which is super, super handy when it comes to these kinds of things. If you guys have any questions, I'm going to pull up the automate and deploy Slack room, and I'll also make sure I pull up the Q&A window for Zoom. I'm happy to answer them. I could go on and on and on and on about Salt and orchestrations, but I think that we want to get to some of the lightning talks. But if there's any questions, I'm again happy to answer them. Happy to discuss this in the Slack channels afterward, or please check out the GitHub repository there. You should be able to just type Vagrant up. Let me go to it for you so you can see it. There is a Vagrant file in the root of this GitHub repository. That's actually going to start up a cluster of machines. Again, it's 5 machines. There's going to be a Salt master. There'll be a DB server. there'll be a proxy server, and then there's going to be, you can actually specify as many app servers as you got memory to withstand, but I put in 2 for right now. And this is all set up to use Salt to get all the machines ready to go. So at any point in time, you can type Salt or Vagrant destroy and then Vagrant up, and it will end you in a state where you can actually see the application running without having to type anything else. So we do have a question. So does SaltStack do active state management rather than just when deploying? Active state management. So the states only get applied to machines in response to a state.apply being called on whatever piece of infrastructure. So it's not actively watching for changes to like the environment to try and correct them unless you put in place a beacon that would do that. So for example, you could put in a file watcher that if there was a rogue sysadmin who is always editing the Nginx conf and putting in something you didn't want to do manually, you could watch that file, and if it gets edited, the beacon can put that onto the event bus, and then Salt can rerun that specific state against fixing that file if you want it. But it's not continually watching the file system unless you explicitly tell it to with a beacon. I hope that answered your question, Adam.